So last time, if I remember correctly, we were here. And here in this, in this section, which is section 2.2, one of the things we're looking at is equations in two variables, in x and in y. So we have an equation in x and in y. Then just like with equations in one variable, we can consider solutions to these equations. But since we have two variables here, the solutions are going to be ordered pairs, not just single numbers. Okay, so the solutions, solutions are going to be ordered pairs of numbers. Basically, you replace x with a, the x coordinate, y with the, and y with b, the y coordinate, like so. Okay. And if after doing that, the equation is a true statement, then you have a solution. That's what happens here with 2, 3. You know, replace x with 2 and y with 3, you get a true statement. But if you replace it with something like this, 1, 3, the equation is not a true statement, it's a false statement. So because of that, 1, 3 is not a solution. So that's what happens here. Okay, so now we did this last time, but this is actually tied to graphs of equations. Namely, if you have something like y equals 2x minus 1, you can actually get infinitely many solutions. So before we get the graphs, let me say this. You can actually get, for certain equations like this, infinitely many solutions, not just one, not just two, infinitely many. How do we do that? You just replace x by different numbers, you know, so that the expression in x makes sense. Then you solve for y. So for this one, for instance, if I replace x by -1, okay, right, -1, yeah. Our y then, okay, will have to be 2 times -1 minus 1, which is -3. So we're solving for y. We're determining what y is explicitly. Hence, -1, -3 has to be a solution, right? So again, we're replacing x by -1, and we're seeing what y has to be from the equation. In other words, we're calculating y so that we have a solution. If x is 0, same thing. We replace x by 0, and we're calculating y so that we have a solution, so that the equation is true. And we get y is -1. So 0, -1 is a solution. And you can keep on doing this for this equation. You know, you could replace x by any number you want, and there are infinitely many solutions. Now, how is this tied into the graph? It turns out, well, by definition, really, the plot of all solutions to an equation in x and y, that's called the graph of the equation. The plot of all the solutions to the equation in x and y, that is the graph of the equation. So if you're asked to graph an equation, what you're really doing is you're plotting all the solutions. That's actually what you're doing. And I think I might have mentioned this last time, but to do that, you basically make a table like this. Although if you can, it's better to use more points, because the more points you get, the better your graph's going to look. Because then you're going to plot these solutions and connect these solutions, you know, kind of like connect the dots in the Cartesian plane. But that's what's happening here. You're going to make a table, of solutions, okay? Then you plot them, the solutions, and then you connect them by a smooth curve. It's not as bad today because, we have graphing software. That is, we have technology that can help us graph, but it's still good to be able to graph things by hand. You still want to be able to sketch, or at least know what the graph of this is going to look like. I mean, this is a line, and in 2.3, we'll see that. And the more points you plot, of course, the more accurate your graph is going to look like. All right. So we have y equals 2x minus 1. I reproduced the table here, although here it looks like I have an extra row. But if I were to plot these points and connect, we would get a line. And you might have known that already, this was going to be a line. If you did not know that, that's fine. But if we connect these, we would have a graph like this. And again, the more points you plot, the more accurate the graph is going to be. All right. Okay, so we have that. So we have a line here. Oh, sorry. Something I forgot to point out. Notice that if we let x be 0, right, the y has to be -1. In other words, the line, right, the graph that is, crosses the y-axis. The y-axis is vertical. It crosses it at -1. It's also going to cross the x-axis. X-axis is horizontal. Crosses it at this number. I don't know what that number is off the top of my head, but we can calculate it. But essentially, these two observations lead us to the next definition, x and y intercepts. So by definition, the graph will intersect the x-axis, right? It's going to intersect that in the point of the form a, 0. So in other words, when you have a graph cross the x-axis, okay, the y-coordinate has to be 0 at this point. I mean, that kind of makes sense because to be on the x-axis, right, when you're plotting a point, you can't go up or down. Your y-coordinate has to be 0. Remember, the y-coordinate tells you how high up or down you go. If it's 0, you're not going up, you're not going down, you're stuck on the x-axis. So this is going to be of the form a, 0 for some a. Here, you're passing through the y-axis, so your x-coordinate has to be 0. If your x-coordinate is 0, you can only move up or down, so you're stuck on the y-axis. And that's what this definition is reminding us. And it's also telling us that here, A is called the X-intercept. So when it crosses the x-axis, it's going to cross at a point of this form, I should say. This A here is what we call the X-intercept of the graph. So this A is the X-intercept of the graph. Here, when you cross the y-axis, okay, B is what we call the y-intercept. That's actually where it crosses the y-axis. So we have x-intercept and y-intercept. This tells you how to find them. The idea is really not that bad. You just basically set the other variable equal to 0. So if you want the y-intercept, you set x to be 0. If you want the x-intercept, you set y to be 0. So if we go back to this, for instance, okay, we actually saw, if you go back to that calculation, let me show you, we had x equal to 0 here, right? Well, if you let x be 0, that forces y to be -1. Hence, -1 is the y-intercept. Okay. For the X-intercept, again, you set the other variable to be 0. The other variable is 0, which is y in this case. You know, x-intercept, the other variable is y. And we solve for x. And here we get x is a half. You know, I didn't show the calculation here, but I hope you can see that visually, that x is going to be a half here. So I hope so, at least you can see that. All right. And this is just another example that we're doing, okay? Actually, before we get to this one, let me pause the recording. If it goes too long, then YouTube makes it harder for me to upload.